So what is cast iron? Cast iron is simply a composite material made from a mixture of various stone and metallic components. It has been used to create a variety of things such as weapons, cookware, architecture, and many more applications in the commercial and industrial world throughout history. Cast iron is a versatile metal and has many properties that makes it an important material used in engineering and various applications. So, how is cast iron made? Cast iron is formed by melting pig iron and carbon alloys that have a carbon content of around 2 to 4%. Then it is poured into a mold and solidified. Since it contains carbon alloys, it is considered a heterogeneous alloy, meaning it contains more than one microcrystalline structure in the material. So let's jump into the history of cast iron a little. In 1200 BC, blacksmiths worked with iron in order to create tools, therefore changing its properties, leading to the creation of cast iron. The Industrial Revolution pushed the expansion of cast iron, having a large impact on changing how metals like iron were produced to improve the industrial world. Cast iron became a more used material in the late 1700s due to being less labor intensive to make than wrought iron. So what is wrought iron? Wrought iron is the first type of iron made of pure elemental iron that is heated into a furnace and formed using hammers on an anvil. So that's really labor intensive rather than using cast iron. Wrought iron was used for its high tensile strength in things like buildings and tools, but was abandoned due to high labor intensity and other products being developed which had superior properties and performance in the industrial world, such as cast iron. Since raw iron contains less carbon of around 1 to 2% than cast iron, which has a 2 to 4% carbon percentage, its structure is softer and more ductile, which makes cast iron a better material to use in the industrial world and many more applications. So these elements of cast iron in its mixed microstructure makes its physical structures strong, hard, less malleable, but also very brittle. So it cannot be bent or stretched into shapes due to its weak tensile strength. It would fracture before bending, but it has a very good compression strength. Its texture is very rough and bumpy due to its uneven, jagged surface, and the colors of it can be classified as gray iron or white iron. And gray cast iron has a flaky appearance, and its gray color is created by the graphite inside of it. Also, gray cast iron contains more silicone, which means it is less hard and more machinable than white cast iron, which contains carbide impurities, but they are still both very brittle. They are very susceptible to corrosion when exposed to oxygen when there's moisture on the material. This is unfortunate as iron will rust over time if the bare metal is exposed to moisture. But to prevent corrosion, paint is usually applied to like cast iron and metals to protect it. So speaking of cast iron strength and durability, we're gonna go to the weightlifting gym and mess around with some cast iron weights to see how really strong it is and see its compression strength. We're gonna be deadlifting some cast iron weights and slamming them to see how they perform. So we're basically doing a strength test and durability test with cast iron. So this is what the cast iron weights look like in the weightlifting gym. They're fully cast iron weights. I'm loading up these plates right here to start deadlifting. So here's some cinematic shots of just the deadlift platform and how the weights are set up. So as you can see in this first set, as I'm picking up the weight and slamming it, the structure is very strong. So this is an up close look at the cast iron weights. The texture is very rough and hard. Of course, there's going to be indents and scratches on the side for slamming the weight, but it holds up pretty well and has a good compression strength. And as I move up in weight and continuously slam it, the cast iron weights hold up pretty well, which is what they're made for. Their high compression rate makes sure there's no fractures or anything. Materials made out of cast iron are very good to buy because they're very inexpensive for their strength and durability. They're made to last and saves a lot of money. During this deadlifting session, this is the most weight I've deadlifted before. So if anything, I would break before the cast iron does. The power of the cast iron is just too strong. It just turns you into a lifting animal. In this video, all the clips I used were from my original content. I did not use any outside videos or sources. So on the screen, I'll put the sources I used for my written portion. And hopefully that is okay to not use outside sources for my video.